product manager gets a feature request that comes in and needs to write a user story. As a user, I want to, any ideas? I want to press a big fat red button so I can
Load stuff up.
blow stuff up. I love it. I love it. Yeah. For a new feature request, to blow stuff up. Only I knew it could do that. So she writes up the user story, puts it in the backlog. Now it's waiting for refinement. Eventually, the team gets to it. Well, it's missing a few acceptance criteria, so they have to send out a few emails, put a few emails back. A few days later, that's refined in the backlog, waiting for the next sprint to come along. Next sprint, a couple weeks later, team picks it up, out of the backlog. Now they have to, I don't know, size it, debate it. So there's a vivid discussion that goes on, maybe 45 minutes. Is it a medium, large, 5 points, 8 points?
Extra large.
Extra large. I hear the giggles. You know the story. You know what it's like. Finally, they get it done. The sprint starts. Okay. Next, the business analyst, the BA, has to make a nice list of requirements. Make sure all the requirements are correct. There are a few things that aren't quite clear. Shoot out a few more emails. Wait a few more days. After a while, work gets done. Check. Okay, we have all the requirements. Next, the architect. The architect has to start working on that now. Make sure everything is conformant with the enterprise standard. I see these nodding. Some of you have been there. Make sure it's all conformant, and there's one of these APIs, there's a few things that aren't clear, send out a few more emails. A few days later, check, okay, finally, the architect signs off. At last, the developer picks it up and start working. So they develop, okay, this requirement, they're developing away, write their unit tests, red, red, red. Green, red, red, green, green, red, green, green, green. Okay, finally, the unit test pass. Check. Send out a pull request, a PR. Okay, now the tech lead has to pick it up, and the tech lead finds that, it doesn't quite conform to our coding conventions. There are a few little bits of documentation missing. Goes back to the developer, another PR, but eventually it gets merged. Hopefully, most of you know what I'm talking about. I see a lot of people nodding along. Now it's time for QA, so the tests get going. All right, they happen to notice there are a few edge cases that nobody thought about. Back to the developer, goes in another loop. Eventually, finally, our explosion feature gets pushed out to the user. 6 weeks, and 6 weeks is when things go pretty smoothly, right? That's how many companies work, the standard kind of traditional enterprise. Let's call that company A. Now let's look at company B. Company B uses AI. They have Copilot peppered everywhere in their organization. Everybody is equipped, they're trained, they know how to use Copilot. Awesome. Okay, let's see how the same process goes with this productive bunch here. Same thing, product manager gets a feature request, but she doesn't have to write it up on her own. Boom, Copilot writes it up, and nicely, and in this case, even better than she could have done herself. Wow, this is amazing. Right into the backlog, waiting for refinement. But now there's an automated process that Copilot picks up, and it annotates it with all the acceptance criteria and other contexts that you need. So we don't have to skip a sprint. The team picks it right up, and they don't have to discuss for 45 minutes because most of the information's already there. 15 minutes max, everything's all decided. Sprint starts. Same thing, the BA gets it. Fine, all the requirements, all written by Copilot, all automatic. Like the BA is laughing. Like there are a few things, because Copilot's not bug fix, obviously. So they still have to validate it, but instead of 3 days, that gets condensed down to a few hours. Amazing, check. Then that architect, same thing. Well, the architect, like there might be, they might have to do a few Copilot sessions because the Copilot has to go out and check all the code base and the entire enterprise. That burns tokens. So, it goes through a few sessions, maybe a day, let's say. But still, condensed from several days down to a day. Architect, check. Then the developer gets it. Copilot, helping away with the code. Copilot's making sure, yeah, this requirement, good, this requirement. Copilot even writes all the unit tests, green, 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 just speeding along, zooming along. Then the pull request, they send that in. Well, now the tech lead's happy because Copilot already put in everything in exactly the way it's supposed to be. So it gets right out to testing. Testing, again, they whiz through this. They even find some edge cases that they didn't find in the last example. So we've condensed company A, 6 weeks. Company B, the AI-enabled company, they could condense that 6 weeks down to 6 days. That's like a 10x improvement. Is that not incredible? That is like, wow, that's what our CBC people talk about in the news. That's what, that's what makes headlines. But notice something. What really changed? Okay, yeah, we made each individual a bit quicker and maybe marginally improved the quality, but the fundamental process is exactly the same, right? You still have the feature request coming in, you have the product manager who has to write the user story. It still goes through the same process, you have the BA and all these, basically, it's the same, I'm gonna say 1970s process, but just turbocharged with AI. Can we do better? Well, let's think of an example. Let's look at company C now. So company C is a little bit different. They've thought of everything from the ground up. They realize that, oh wow, this technology, this allows us to really think and do things in a completely different way. We don't need all these silos where we have, all these specializations where, let's be frank, a lot of the people in these silos are more sort of concerned with perfecting their work than focusing on the actual value you're delivering to your customer. So a lot of what gets burned is the overhead of complying with all the rules of your specialty. Every time you have a handover, you have to re-explain the context. So what you're actually delivering, this explosion feature you're trying to deliver to your users, it gets further and further away from the actual discussion that you have. And the discussion is more centered around all these, I would like to call incidental or sort of unrelated technical constructs. So company C, who understands this, they say, okay, let's do this differently. Instead of having a team of all these very specialized people, let's collapse the team. So it's basically a team of one person who may not be the deepest expert in each of these, but who has enough knowledge of product management, of requirements gathering, of architecture, enough to really focus on this, can I say terrorist feature? Was that I didn't make it up. So you have this one person in the center surrounded by now these AI agents. And what we can do now is from company A, 6 weeks, to company B collapsed roughly 10x into 6 days. We can collapse it further, another 10x, into about 6 hours. That is what I'm calling AI native, and that is the topic of what I'll be presenting today. So my name is David Leangen. I've been a technical leader for about 25 or so years. and an entrepreneur. My first company I founded in 2000, which it always makes me chuckle to say now. It was an AI company back in 2000. Of course, AI looks very different now from when it did back then. Currently, I work at a startup based out of Vancouver called Miraterra. We do soil health technology. So soil health is really, I guess you could say, a problem of our times. 95% of what we eat comes directly or indirectly from the soil. And about a third of the soil on the planet is unhealthy for various reasons, over-farming, monocrops, different reasons. So regenerating soil, ensuring that soil is healthy is really an important problem of our times. There are a few things that are really interesting about this company. One is just the range of technologies. So one is we do soil measurement. We have what's called a digitizer. It's kind of like a scanner, but for soil, based on Raman spectroscopy, that helps you measure the different minerals and even biological components in the soil. So we measure chemistry, biology. There's even geospatial analysis. So that creates tons and tons and tons of data, different types of data that needs to be analyzed. And in the end, the result is you have agronomists, so people who consult with farmers, people who need to understand what should I grow this year? How should I, what should I put in my soil to get better yields, or even to make the crops more nutritious? Questions like that. Important stuff, and it is very, very technical. But a few things that are really cool about this is it's a unique company. It's been around for 10, 12 years doing a lot of research, but it's just kind of got new life. Actually, literally yesterday we just received another $16 million in financing. And so we consider ourselves a startup, even though it's been around for a while. There are 50 people, so it's neither big nor small. It's been around long enough that this traditional approach I was talking about, it applies, but yet it has that dynamic startup feel to it. It's big, but not too big, and so there are a lot of really neat things going on. But what is most interesting is this push to go AI native, and that's where I come in with the company. My role is to take the company from being this traditionally operated startup to going AI native. So the talk that I'm giving is not completely theoretical. There is some practical experience as well that I can share. So let's get into it. The first thing I'd like to talk about is this concept of the enterprise as a knowledge system. So what do I mean by that? Let's think about what does an enterprise actually do? Now, being an engineer, I like to think of things in terms of systems. So this is we're missing the that doesn't work too well. Anyways, we're missing the function in the middle here. But as any function, you have an input and you have some kind of output. If we look at the enterprise as this system, the inputs, let's say, are information. And what you're trying to get as a result is some value that you're delivering to your customer. Great. So what does that mean? Well, the transformation, the way we transform the inputs into this value, the main activity is reasoning. So for most organizations, and I'm gonna focus mostly on software just because it simplifies the topic a little bit, but for most organizations, the primary activity is reasoning. But it's not just, like here is just a straight out function. It's not a one-time thing, because you're always learning, you're always improving. Oh, that didn't work. Oh, something changed. Oh, now there's no oil coming in 2 weeks, or whatever's going on because of the terrorists. Sorry, you got me going on that one. It's all you want. So now we have this site. It's a feedback loop, right? A feedback loop that you first you need to decide what are we going to build, and you build it, then you execute it, and you look at the results and you feed that back into the system. So it becomes sort of a self-correcting system. It's just classic systems engineering where you have the feedback loop to stabilize the system. Okay, fine. But when we look at the enterprise as a system, traditionally, we have the people on the outside building this thing, whatever the thing is. It's a system we're developing. So that feedback loop that you're looking at is really the people building this thing, putting it out in the world, and then now they have to talk with each other and think, okay, what's going on? Is this working? Is it not working? How do you think? So all the discussion, all the learning, everything happens outside of the system. That's all external. But in an AI native context, we go from being external actors of the system, and now we're inside the system. So we have now two categories of actors, and I'm going to come back to this one. But now inside the system, as part of the system, we have the humans acting with the agents. Now, this may sound like a little subtle idea, yeah, whatever, but this is actually a fundamental change in mindset. And it makes a very big difference when you're considering this idea of AI native. Let me just share some vocabulary just to make sure when I say certain things, I want to make sure that we're on the same wavelength, that you understand what I mean when I use these words. Starting with enterprise, we just saw that it's a system that transforms inputs into value in a sustained, coordinated manner. That's the definition I'll be using. So if we layer on top of that, a knowledge enterprise is an enterprise, but whose primary inputs are ideas, and therefore the primary transformation is reasoning. Remember, we're talking about AI, right? So AI and reasoning, they kind of go together. Now, an AI native enterprise is a knowledge enterprise in which AI systems are structural participants in the transformation of ideas into value. So I will go into this in a bit more detail, and hopefully that'll make more sense. Which leads us to the agents. The agents as these first-class participants, the first-class actors in the system. What is an agent? What do I mean by agent? Because different people use different definitions. I don't think there's really a standard definition. A lot of people say, well, it's something with agency or whatever. I'm defining that as a design participant. It's basically it has a role. So the role means what it is, what it does, how it reasons. It's something you design, and it's not just a set of prompts, and it's not a tool. So it's something that has a very specific purpose and role. It has a goal, so it knows what it's trying to accomplish for any given invocation, and it's very specific. You don't give it a general concept, so you give it a very specific goal. And it needs to be able to communicate with systems around it, so it has interfaces. It can communicate through REST interfaces. MCP is a big one. I mean, whatever, it doesn't matter, but it can't be isolated on its own. It has to be able to interact with the world around it. And it has a life cycle. So it gets instantiated, does a job, and then it gets terminated. So these four characteristics, that's what I'm using to define what I mean by agent. So now, as we saw, we had in this enterprise system, we have these two types of actors. We have the human actors and the agent actors. So now that brings up the question, how do they actually work together? What is the difference between them? Let's start with that. So if we look at the human side, humans have multiple roles that we can assume simultaneously. I'm an engineer, I'm an entrepreneur, I'm a father, I'm a husband, I'm a smoker, I'm a joker, I'm a...
Good joker.
Thank you. I don't know, that just popped out of my head, sorry about that. Thanks for not groaning at that one. So humans we have a single instantiation. There's only one of me, but yet I can assume all those different roles. Us as humans, one of the things we're good at is accumulating context over time. Some people remember things differently, and some people are good at remembering some things and not other things, but in general, we remember things that we experience, we have this context that we build up, which gives us judgment, creativity, intuition, these kind of human qualities that these agents don't have. I mean, they can simulate, maybe, but inherently, and I don't want to get too philosophical, that's not the point of this discussion, but just roll with me on this one, that if we consider these as human qualities, these are something that the humans have that the agents don't have. So we, in the system, become the irreplaceable decision makers. That would be our principal role. Agents, on the other hand, notice this is interesting, that these are the opposite. So we have, as humans, a single instantiation, we play multiple roles, but the agents, they have a single role. But they can be instantiated multiple times. So you can have a single agent, but like 1,000 copies of them running at the same time. So it's kind of the opposite of what humans do. Their context is very bounded. I mean, you probably, anybody who's used Claude or whatever, you're very familiar with that it only knows the little context that you give it. And otherwise you have to give it memory. You have to really arrange the context because it doesn't know anything at the time it gets instantiated. So we need to, as humans, our job is to really understand that context, understand the goal of what we're doing. The agents are really good at analysis, generation, pattern matching. They can do stuff in an amazing way that we can't. So they're like a tireless specialist. So hopefully this starts to give a picture of how these two actors, these two different types of actors, can work together in this AI system. So the goal, going back to that company A, is not to have these little silos of specialists. That's gone now. Now we have to think about things totally differently from the ground up. So we want to stop building general purpose agents and design systems as specialist actors. Okay, great. Just a quick note about what I'm talking about here, because there are two different, let's say, environments where these agents live. One is at runtime, the other is at, let's say, build time. So at runtime, those are the ones that you're putting out to your customers. They're the, the chatbots or whatever that your customers interact with to ask questions about your product, or however it's integrated with your product. But I'm focusing here on the developer agents, because I'm talking about the enterprise as a system and how we develop these products that we take out to our customers. So code generation and factoring, test writing, all these activities that you do at build time, that's what I'm focusing on here. Okay, so now we have the idea of this enterprise system, this knowledge system. We have human actors and agents together in this system, and we kind of understand the differences. How do we get them to work together? And this takes a little bit of thinking, because these are different. Something's different about these AI tools than typical tools that we use. Like it's not Excel, it's not Word, it's not little tools that, it's fundamentally different. So we kind of have to rethink how humans interface with these agents. So the first pattern I saw, and it's these, I guess are kind of obvious, so it almost seems silly to talk about them, but yet there's a truth to it that somehow seems really important. It's treat agents like colleagues. So basically anthropomorphization. And I'm going to say that word again because I had to practice it for 20 minutes before I could say it without getting tongue twisted. Anthropomorphization. It sounds simple, but it is a powerful tool. Why is that? Because as humans, we're hardwired to communicate with other people. It's just natural for you. Don't need a manual to know how to talk and interact with people. Now, of course, for some people it's easier than others, but generally speaking, like when we see a person, like we know what to do, right? So it's the more we can make the agents like people, the more intuitive it is to use them. So how do we do that? The first thing is we give it an identity, so a name and a role. The name could be kind of generic. You could call it like a requirements agent. You could call it a reviewer. Here I put Gabe because at Miraterra, where I work, the agent that we put out to our customers is called Gabe. So they communicate with Gabe, right? It's almost like you're talking to a person, but that's kind of the point. So people immediately know how to engage when it's something that appears human-like. And the other one is a purpose. So what is it here to do? Better if it's specific. So if somebody sees it like something person-like and knows what it does, then it becomes really easy to interact with. You don't need a manual, you don't need like guides or like contextual help or whatever. It just becomes really simple. So that's the first pattern, anthropomorphization. The second is governance. This also sometimes sounds strange or, I don't know, technical or whatever, but it actually is a pretty simple idea. As humans in society, for at least the last few centuries, if not millennia, like we've had to figure out how to live and work together, right? And how do we do that? Well, we elect a president, or we form governments. So we need to figure out how our governments work. We have tools, like we have a constitution, we have charters, we have laws, and all these things. Now, we're not all lawyers here, but we're used to working within that system, so we kind of get an idea of how that works. We understand government, which means that we can understand governance. So governance is something that becomes one of these intuitive interfaces, because it so happens, well, first of all, on the human side, like I said, we've been doing this for a while, and it's something that we understand pretty naturally, but it turns out that the agents understand it too. So it becomes a really intuitive interface between the humans and the agents. All right, so we've talked about knowledge enterprise, people, agent, how they work together, some of these patterns and interfaces we can use to make it work. I'm going to just kind of rattle off a few different things that I've learned sort of practically along the way in this exercise. Now, I do have to say that we're still very early in this journey. I haven't yet met anybody, any other company who's doing quite the same thing, because the larger enterprises, I mean, what I've talked about so far today, it's not really practical for them to completely reorganize themselves. They're going to continue with the same old processes, but with the co-pilot everywhere. So what I was calling AI enabled, they'll continue doing that. Maybe a lot of, some of the newer startups that come out, they start out AI native, but companies like Miraterra, where we're moving from that traditional and reorganizing to become AI native, there are probably fewer of us. So we're, like I said, we're still at the beginning of the journey. So I'll have to kind of check back with you all in 6 months or a year or something to see how it actually goes. But these are some of the things that I've discovered so far. First of all, as we said, the enterprise is the system. It sounds like a subtle idea, but it turns out to be very important. So the enterprise itself needs to be redesigned to accommodate humans and agents so they can work together. Things like, what we've decided very early on is we don't give the agencies any kind of independence, in the sense that every action they do, it must be traceable to a human actor. So if an agent goes out and spends, $20,000 on building a bomb, then that will be linked back to a particular individual. Code is a specification. So as you've probably experienced, if you've used Claude or whatever, it can drift over time. You have to continuously give it context, but over time, oh yeah, I want to build this, and then over time, you kind of end up going this way when you intended to go this way, and then, oh no, that's not working, and you try to get things back on track. When you're using natural language English, or, well, we use English, whatever language you use, that tends to happen. And what works a lot better is when maybe you've heard the term specification driven. The way I interpret that is not using English for the specification, but using maybe Java or Python or something like that, because it's much more precise. So if you code as the human, you code yourself by hand, or aided with Copilot or whatever, that doesn't matter. But you are responsible, you understand very deeply and in detail the code. Then what gets generated from that is much more likely to be, because remember, this is not, when the agents work, it's not deterministic, right? There's always an element of surprise, shall we say. There's always going to be a little bit of variation. So the better specified it is, the better results you'll get. The third one is governance is not optional. We just talked about that. It actually becomes quite essential. And there are a few different things related to governance, but for example, the way we have it, we have 4 different layers. So the first layer is the responsibility of the CEO, and the CEO literally signs off on it and says, yes, this is what we want to do. I authorize this, so the CEO takes responsibility for that top layer. And then in layer 2, we have our digital systems team, who takes responsibility for how the systems get deployed and all that kind of thing. So there's an element of responsibility. There's this is what we can do. This is what we should. This is what we must not do. That is in plain English, and the agents. It needs to be understandable by both the humans in the enterprise and the agents also understand that. Design from scale for day one. Now we're a 50-person company, but remember now we're 50 people. But if we consider these agents as first-class actors in the system, well now we're not just 50 actors, we're 500, maybe 5,000. So suddenly, from, I guess you could say an IT perspective, we're no longer a small company. If you have the agents developing with you, building these systems, this is massive now. So you cannot develop your systems the same way. You have to design for scale right from the beginning, or else it's going to break down very quickly. Git is amazing. Don't underestimate what Git can do for you. It has a lot of really great features you could use. One thing, if you are a Git user, look into intentional commits. It's a very simple idea, but very powerful. Use Git to write the history, because the history, remember, it's all about context engineering to make the agents work the way you want them to. You have to provide them the right context at the right time. History turns out to be a really good way of providing context, just one facet of it. They don't get everything from the history, but when you need it, it's very powerful. So use Git as memory from all your sessions. It's great for tracking memory from session to session in quite a lot of detail as well. It just becomes a very powerful tool, but you have to write meaningful messages, and we all know, like, everybody's that way. I hate writing commit messages. I suck at it. I'm usually like, oh yeah, more work. Oh yeah, fix. But like, it'll always be like really simple, useless messages. The simple fix is use your agent to do that for you. You don't use Git directly anymore. You use it through Claude or whatever. And Claude will do a great job at making those very nice commit messages for you that create this beautiful, elaborate history that you can come back to. And it really pays dividends to do that. And then I was talking to Sorry, I forgot your name already. What's your name? Yes.
Go.
Kevin. We were talking, because you do project management, and we were just talking about that before the talk, that project management skills are really valuable when you use it for the agents. Like you can leverage those skills to organize your work very well. It's also a very powerful tool. Okay, so yes.
Question about point number 2. You pointed out that
Point number 2?
number 2 on the previous slide.
Yeah?
Code is spec.
Yes.
Specifications drift, code doesn't. Could you clarify that? Because what actually constitutes a good specification in your experience? The reason I'm asking is because code does drift. I mean, that's kind of the point of an agent, is right to rewrite your code to make it better. So in your experience, what makes a good specification, and how does that differ from the code that the agent produces?
Yeah, that's sorry, what's your name?
Kevin. Also.
What? It doesn't take much to confuse me. Hey Kevin, how you doing? Okay, Kevin, simplify it for me, thank you. No, it's a great question. It's probably just not quite written the right way. So let me give an example. Like I really happen to like, I don't know if you've heard of domain-driven design. It's actually making quite a comeback now because it really helps to sort of clarify, put things into context for when you're using LLM assisted development. Or one thing you might want to do, are you familiar with like dividing like interface and implementation?
Yes.
Okay. So that's kind of what I mean. So you write the interface yourself in code. You be responsible. Don't let the agent just do it for you. So I would not specify in English the interface I want the agent to write. I would code that interface myself. This is what I want. And then the implementation code, you can let the agent write. And in fact, what I would do is take a step further, is because I have this sort of way of writing the interfaces, that I use agents to write what I call generators to generate the code. So what that does is when I update the interface, the generator is, because it's generated, there will always be potentially drift and things like that, but over time you can fix that. But every time I make a change to the interface, the generator is fixed now, and it'll actually generate deterministically the code. So you can use techniques to try to add in as much determinism as you can, so you get away from the surprises that we're talking about.
Yeah, that makes sense. Okay, thanks.
Good. Okay. So consequences. Company A to company B, I think we agreed, or at least I did, that it's basically just moving faster, but it's kind of the same old thing. But now if you move into this idea of AI native, it's not just faster, it's different. And that has some interesting properties. So one thing is the length of the feedback loop when you're developing your product determines, it seems to have a tendency to determine the ambition of the questions you even ask. If you know that to create your exploding feature, if something is different, or you learn, or say you're almost at the end and you realize, we should have done it this way, you're much less likely to actually make the change. You'll be like, well, we've done all this work, and I'll take another 5 years, let's just go with it. The longer the feedback loop is, like, because of that dynamic, the less ambitious your questions will be. What if we did this? What if we did this? Your bosses will be like, shut up. Like, we're not doing that. We can't do that. We're on a budget. We're on a timeline. Come on, just write your code. But so when you're AI augmented, like we were talking about, they're longer cycles, so it's more defensive kind of thinking. So you don't necessarily ask the best questions. But when you have that really quick loop, you can be more bold. You're like, okay, I just spent 2 hours writing this complete web application. Oh well, you can just throw it in the garbage, and it was 2 hours. It wasn't 2 months, right? So it's a lot easier to be much bolder. So what that does is, you have more time to think, be creative, think bigger, or think, like I said, bolder, and make bigger decisions. The other consequence is that it now becomes a self-learning, self-healing enterprise. Because remember, we're not outside of the system. Now we're inside the system, and we can reason about the system. So being inside the system means that now the system is able to reason about itself, and is able to correct itself, and heal itself. So yeah, traditional, observing from the outside, AI native, we're observing from the inside. So we catch problems much quicker. Yes?
So are you suggesting like that these agents are still like taking the same roles, or are you saying that the whole process is completely different? I mean, you still need the product manager and the engineer and the architect. And are you just creating agents for those particular things, or are you throwing that whole system out the window?
That's a great question, and I probably should have put a slide to clarify that a bit more. What I'm suggesting is, in the traditional enterprise, just because of the complexity of what we're doing and the way we've kind of learned to work together, is we have these silos especially, like we were talking about the business analyst, the architect, and you have a developer, and you might have a security expert, and then you have DevOps. And what tends to happen in that kind of environment is that the people like, oh, I'm a DevOps specialist. So I go to a DevOps conference, I read DevOps books, and I get in my own little DevOps bubble. So when I do my work, I'm not thinking front of mind, oh, we're building this feature for my customer. I'm thinking, oh, I'm DevOps, so I gotta do my DevOps job, and you become kind of distant from the feature you're delivering. So that's in the traditional sense. Does that make sense so far? Okay, so now to answer your question then, how can we fix that? Well, one pattern that seems to work really well is to sort of collapse that whole team. Because you really, like when a DevOps person works, or a BA or whatever, they kind of go overboard a bit. Like they put in too much DevOps-y stuff that really is not providing direct or value directly to the customer. But everybody's doing this. So it means the way that you're building the product and taking it out, it has all this complex stuff baked into it that you don't really need. But that's how the industry is developed. When a person comes out of university, or when they take like a Google or a Microsoft certification, they learn, oh, this is DevOps, this is how you develop software. And so a lot of the younger developers think, oh, this is software, this is how you develop software. I'm saying, no, it's not. Some dude made that up, and over time, we kind of accepted that as the way things are and must be. But who said so? Like, why? Like, what? So really what this is allowing us to do is kind of rethink everything from the ground up. So if you no longer need all those specialties, then what do we do, to answer your question? We can, the way I look at it is we collapse all those roles into one person. I call that a business engineer. This person understands the product. That's the main thing, is they understand the product and what you're taking to your customer. They understand the domain. That is front and center, because that is the reason they're there. But they have just enough product management knowledge, just enough architectural knowledge, supported by these specialized agents around them. So you might have like an architectural agent, and you might have like a CI/CD pipeline, or like a DevOps agent. And so you have support from your agents to help you accomplish that goal of delivering value to your customer. Does that make sense? Because it is a bit abstract.
It's a bit abstract, I would have to say, but because you're basically throwing out the traditional roles, or maybe those roles are still there, but they have to have an overview of the end goal.
The roles are, that's a good question. Are we throwing out the roles, or are we just kind of changing them a bit? The way I put it, I think you're right. We are throwing out the roles, but we're not throwing out the knowledge. Like, I was saying earlier to Kevin is we're not saying no. Everything we learn about project management, like we've learned a lot of good stuff. Like if you go to get your certificate or whatever to be a project manager, I'll give it. They have this big thick book they call the PMBOK with which all the learnings, the body of knowledge for project managers. It's still all good stuff, or a lot of it is good stuff anyways. So we don't throw out the knowledge, but this role of a project manager is probably less important. So we're taking the same knowledge, but we're just forming different roles would be maybe another way of explaining it. We can talk more after today. Yes?
I just wanted to build on that mode of experience too, in that depending on where you are in your journey becoming sort of the AI native orchestrator on your own, those roles are baked into a lot of training that's aimed at data. So you can for sure set up agents yourself that will walk you through that pipeline and help you learn as well as you go through. It's one way to do it, or similarly, being the person that knows enough about everything to get through.
Yeah, totally. Because I think that's related to what you're saying, but like now, you just need to know enough about coding, enough about architecture to do it. You don't have to be like, oh, what is the syntax for Python, like after this, like, you have the agent who will do that for you. Like, so we don't have to waste brain cycles on that kind of stuff. So the energy we use, the brain energy we use, is more directly applied to actually what we're building for our customers instead of all this other stuff, if that makes sense. We do have a question period. I'll just get through the last few slides. Are we good for time still?
Yeah, we've got 10 minutes, so that's perfect.
Okay. I only have a few slides left. So, what comes next? So, based on all these things we talked about, now this is more kind of speculative, things that maybe call it a wish list, if you will. But first of all, let's notice that the gains compound. I'm making a few assumptions and a few, rounding things off a little bit, but we are calling the traditional enterprise, if we call that 1X, we went into this period of digital transformation, which, you put everything online, now everything's software based, and now everything's 10X now, okay, fine. Then we talked about that company A from earlier, which is another 10X improvement over the traditionally, digitally transformed company. And I'm speculating that AI native would give us yet another 10X gain. So that speed will compound over time. But then the question is, so what? Like, is that what we want? Like, don't we have enough crappy software out there as it is? Like, do we want more of that? Is that really the kind of, society we want to move towards? I hope not. I don't know about you, but I get very frustrated about, how technology works, or I should say, doesn't work when I need it to, when I need to download an app, or just to, join my Zoom meeting. Now I have to do a software update. I mean, all these things that go wrong, that's enough for me, right? So, do we really need to put the pedal to the metal like we have been doing it? We have been optimizing, like if we're optimizing for another 10X speed, it means, we want to deliver faster, maybe lower costs, like these are the things we've traditionally been optimizing for. But what if instead we try to optimize for quality? Because now we have a different, maybe better way of working thanks to these agents. Now we can use more of our creativity, more of our, less of the technical geeky thoughts. We can think, bigger, more boldly. So we can have a deeper understanding of problems, or maybe attempt, higher impact problems. At least think more deeply and more richly. Like, I hope that that's where we would want to put our efforts instead of just trying to accelerate things. That's what I have today. I'm happy to answer any more questions. Rob put his hand up really quickly.
I have to jump in. Going back to that point number 2 about the code is the spec or the spec is the code.
Okay.
That really hit home around the reducing the non-deterministic behavior of tools. How does that translate for a non-developer user, such as myself, who's developing lots of tools and projects and gems and that sort of thing? How does somebody without coding experience go down that road?
That's a great question. I often use an analogy because when I started my first company, we like I said, it was AI, and we needed to apply it to something. So we decided to go into the life sciences. Okay, to me that sounded niche, but that turns out to be a huge domain on its own. So at that time, bioinformatics was just an up and coming thing. There was no such thing as a bioinformatician. That didn't exist. Now they're everywhere, but that didn't exist back then. So what did you do? And what is bioinformatics? It's basically applying computer science and computation and things like that to biology. So looking at biology as a system and looking at that computationally. So what did we do? Well, you get a biologist and you get a computer scientist, you put them together and they'd be kind of effectively together a bioinformatician. And then over time, bioinformatics became a field, and now we have lots of bioinformaticians who, as a single person, they're able to do that. So what I was calling earlier a business engineer, it's kind of similar, because a business engineer, you understand the business domain, you understand how the business works, you understand how to deliver products to your customer, that's the business part, but yet you also understand systems, how to code, how to work with these agents. The thing is, right now we're so new, everything is so new, that there are very few people who have that combined knowledge. So if you see an association with that analogy I gave, I guess the way to solve that in the short term is you, with the more business knowledge, you sit down with some geeky person with the computer science knowledge, and you become that pair who works together. That would be my suggestion. If you don't, you're in danger of getting a system that kind of explodes like a new system, or other things can happen.
Thank you.
So agents.
Yes.
So I'm assuming you train the agents to do what's doing. So for example, a cluster. How do you do that, and can you provide like a really basic example with your company?
Yeah, unfortunately, I don't have an example paired. And in a way, training is kind of the right word. That's where this
Context.
that's where the context engineering comes in. And so in context engineering, there are many different ways to do that. Can take a bit of trial and error. And you need to kind of approach it from different facets, is what I call them. So we talked about the historical one, we have the governance facet. There's just each agent, the way I would set it up in terms of the governance is I would give it a charter, which I guess the industry standard would be like an agents.md file would be kind of the similar thing. So when you spin up the agent, it has its basic set of instructions. And now you have other tools you can use, like skills that you can that the agents can call. Like there are a whole bunch of ways. Maybe this is a better one that we can talk about after the presentation, if that's okay.
Yeah.
Okay.
I'm just thinking about, so I created my own writing agent.
Nice.
So I gave it my best articles, and then I gave it like rules, like
Yep.
whatever you come out is always factual, things like that. So that's helping me. So I'm trying to relate that to what you mentioned
Yeah.
Is that the way to do it?
That is the way to do it, and then the further you take it, because you keep refining it, and then just over time, it gets better, and then you start adding
It's a
in.
iterative process.
It's an iterative process, but, I mean, that's a gross simplification, but yes, thank you.
So getting it back again to this code is the spec.
This one?
Yeah,
This
so
one, people really like this one.
You have the humans and you have these other actors
Yes.
inside the enterprise. And it used to be that all the actors were humans.
Yes.
We could call them wetware.
Hmm.
Now we've got wetware and software working together.
Mhm.
And it kind of reminds me of when we had lots and lots of computers,
Mhm.
and then we went to infrastructure as code, and we could
Mhm.
spin up stuff like
Yeah.
really, really fast. Is it a useful analogy to refer to that as working relationships as code?
That's a good idea.
Yeah?
Yeah, I think so. I mean, it goes along with that, idea I was talking about, anthropomorphization. So it's a working relationship. You look at this agent as your coworker, and you have a relationship with your coworker. So to me, that makes total sense. Yeah.
Yeah, as an individual, working for a large organization that's AI enabled, you touched on field at the time starting this talk here about AI product managers.
Mhm.
So this is gonna be in demand field, I imagine. What are you seeing in 2026 for needing that integration between like development and organization? And whether these product managers are gonna become internalized inside
Hmm.
these organizations?
Yeah, great question. I mean, what I can say is, I've been a product manager myself, and so I sometimes follow people who, like, it's been, it's not my main focus, but I played that role. And because of that, I've been following people who do that, who live it, breathe it, like that is what they do, what they teach. And if we go on what they're saying that, oh, you like, if you're not using AI to do this, you're already behind. And so all the courses that they're offering is all AI focused and all that. What I'm wondering though, is that using the sort of traditional approach or not? That said, like if we go back to how, maybe at this point it's more speculation. Like just because our company is going that way doesn't mean the industry will. But if that does happen, where these teams get collapsed into teams of one person, you're still gonna need communication between the teams. That is not gonna change. The only thing that goes away is within a single team, all those extra lines of communication and between all the silos, that will go away. But you'll still have teams focused around particular features or particular elements, and that still needs to be coordinated. I don't think the product manager role is gonna go away.
Yeah, thanks.
Just wanted to mention, we're on the hour, so permission to leave if you've got to get back to work. Don't worry about getting up. I think, David, you're probably happy to take a few more questions, and then,
Sure, yeah.
yeah, there's always room afterwards to discuss as well, but yeah, go ahead, take more questions. Like I said, please, don't feel self-conscious about leaving or grabbing a coffee in the meantime.
Sure, I'll just wait 30 seconds so people can leave without feeling that. Yeah, thank you.